everyone. So today we have a person who is in between technology and sport and basically creating a future. He worked in ESPN, he worked with NCAA teams and all of just introduce yourself from your words.
Yeah, thanks for having me. I'm Alok. I work at full time at Google as a developer advocate on Google Cloud, which means I demonstrate and talk about how to use Google Cloud technology to do certain things. In my case, it will be data science, generative AI. I also come from a sports analytics background. As you said, I worked at ESPN. I was a founding member of the analytics team there several years ago. And since then have worked on many sports projects at Google, and also do some consulting outside of Google with sports teams and leagues.
Awesome, awesome, Alok. So really great big experience. I would like to understand like what was the most interested project for you that you participated in, like wow project.
Yeah, I think many different projects will come to mind. I
Mm-hmm.
think in the recent years, it's different projects in terms of applying generative AI to
Mm-hmm.
and data science together to look at a sports example. So, we can talk about a few different things. The recent one is a demo I worked on with a bunch of colleagues at Google Cloud for AI basketball coach. So,
Mm-hmm.
this was a more of an in-person demo. Actually, we were running at a couple of the conferences, and now it's running at other events around the world, where folks came to the conference, and then they saw this little bit basketball court. They took a shot, and we give them feedback on different aspects of their form, and it's all based on sort of AI, computer vision, as well as generative AI to figure out how to evaluate the shot, give it really good feedback based on like actual basketball coaching, and then package that into a nice takeaway that they can actually use to improve their form. So I think that sort of thing is probably the most interesting recent project I've worked on. Plenty of other ones from all across the spectrum too.
Yeah, let's talk about this recency and let's talk about the project. So, like you mentioned, if I understood correctly, the project was about trying to understand are the mechanics of the shooter are good enough,
Mhm.
biomechanics, and then translate it for feedback to him.
Yep. So the idea is also to do this sort of low cost and like not with advanced equipment. So
Mm-hmm.
you and probably many of your listeners are familiar, if you go into like the highest level professional sports, they have this motion
Mm-hmm.
tracking data. They've had it for several years, even more than a decade in some sports. The NBA, for example, has cameras installed in the rafters of every arena, and they track the players and the ball multiple times a second. More recently, they also track the limbs and everything on the player. So if you have that, great. But of course, that is really expensive, right? And that
Mm-hmm.
is often only found at the kind of highest levels of the sport. Or maybe in U.S. college sports where they
Mm-hmm.
the highest levels of that as well. But for sort of like generic tracking, the state of the art computer vision, and then with generative AI coming along, there's ways to track some of these things with simply phones, right? So smartphones. So in our
Mm-hmm.
case, Google demo. So we have Pixel phones. We had a few Pixel phones set up around the court. We did it in a couple different ways. One of them was with 6 phones. One of them was with 4 phones.
Mm-hmm.
And basically, with the phones, you can now capture different points, right? So we have one kind of
Mm-hmm.
facing alongside the shooter, one facing them from the front, one from the back to see the arc of the
Mm-hmm.
ball. All these different cameras can come together to track different aspects of the person's shot, whether it be their elbow, whether it be their position of their hand, where their feet
Mm-hmm.
are relative to their toes, and then the ball in the air as well. So the idea was basically to capture as many of these types of metrics as we can, and then get as accurately as possible, and then compare them to a baseline of what we had. And we had data from the Golden State Warriors, who's a Google Cloud partner, that gave us some information of what is the ideal angle and where should someone's elbow be when they release the ball, and all these sorts of
Mm-hmm.
things. Compare the person's metrics versus those kind of ideal metrics, and
Mm-hmm.
then based on that, give them feedback. So that was kind of the idea of the demo.
Alec, I'm listening to you, and I was playing ice hockey myself, all right? And when I was around 16, what I was trying to do, I was watching NHL players' mechanics, how they shoot, how their wrists going, and
Oh,
etc. And I was recording myself and comparing like every millisecond. And if I would have a tool like that, I'd
yeah.
probably be playing hockey right now, not recording a podcast.
That's right. You might be playing in the Stanley Cup final and not talking about this. Yeah, I think the potential is very high
Hmm.
in those cases. Like you said, amateur, youth sports, and even lower leagues and stuff. May not always have the best equipment available. So I think like
Hmm.
this again, this is a proof of concept, a demonstration to kind of inspire people to think. But it's cool to see how far the progress has come, where you can do something reasonably well with this amount of technology, and then AI kind of running on your phone, and some in the cloud, and you can get pretty quick feedback on every single thing. And of course, the idea is, and we're working towards this, is to make it more real time.
And how quick is it currently?
Yeah, I think the way we had set it up for this demo, it takes a couple minutes after the person shoots.
Hmm.
But we were trying to get really high fidelity data. So what it was actually doing is like some of the things we would track on device, but some of this would require calls um, to a Gemini, right? So our large language model, Google's large
Hmm.
language model, Gemini in the cloud. So we'd upload the video, and we wanted to pull off certain points of the video that are very significant, right? So when you're in your crouch, when did you
Hmm.
release the ball? And then those, to pass to multiple passes over the video, that takes a little bit of time. We pull out the
Hmm.
frame from that video, and then do sort of pose data analysis on there using a technology called MediaPipe. So then it says, like, from this frame, when the person's in the crouch, go track their knee and their toe, for example,
Hmm.
right? And then see what's the alignment between their knee and their toe. And ideally, they're perfectly aligned. In some cases, people's knees are too far forward. Some cases, they haven't bent their knees enough, right? And like that's the part. So we have multiple sort of services to do that analysis. At the same time, we're tracking the ball, put that all together, compare it to the ideal, and then another piece of generative AI is to turn that into actionable coaching feedback, right? So
Hmm.
if it says like, hey, your knee is not over your toe far enough, then we'll probably say something like you should bend your knees more. If your knee is too far over your toes, we might say, hey, keep your knee more aligned with your toe to preserve your balance when you shoot. So all of that is personalized coaching, right? But it's grounded in like what you actually did. So each piece of this is not super slow, but when you combine all of these, it takes a couple minutes right
Hmm.
now. But what we were doing is we would have people, we had at our in-person demo, we had a coaching screen. Once they shot, they waited for a minute or two, come around, we talk them through their analysis. They got this takeaway of like, here's your elbow. Okay, your elbow was aligned here, here. Your knee, the ball, maybe shoot it a little higher. The ideal is 13 feet. You were at 11 and a half, something like
Hmm.
that. So we had really good kind of like granular level feedback to give to these folks. So I think it's worth the wait, but of course, ideally with time, this would be quicker.
Yeah, of course, but 2 minutes it's still not long.
Yeah, I think it's a trade off between accuracy and latency, which is often the case in a lot of these in anything, but also with generative AI. We actually have different models. We have a model called
Hmm.
Flash. That's a fast one, right? And it works
Hmm.
for a lot of good things. But there's certain cases where you want the higher level model, right? Which is in our
Hmm.
case called Gemini Pro. And it's a trade-off, and we were testing this continuously. Like, can we use Flash for this? No, we need Pro. Can we use Flash for this last
Hmm.
part? Yeah, we can, and then speed it up. So that's kind of the iterative process combination with some computer vision techniques that some of them are meant for being on device, and that is super fast.
Hmm.
Could you use a different computer vision model that might be more accurate in the long term? Maybe, but that might also be more
Hmm.
expensive in terms of cost and latency. So all these sorts of factors we were working with and trading off to figure out what makes the best experience. But again, it's a proof of concept. So if in your case you're like, yeah, I can take a few minutes, I'm not going to do this live. I'm going to process everything
Hmm.
from my session after the fact. Then you may be fine with a slower thing. Or it's like, no, I want this to be as live as possible. It might make different.
Mm-hmm.
design decisions.
Really interesting. So you've mentioned that basically you have four cameras minimum, or how much cameras do you need?
Yeah, I think we had it down to four for one of the events that I was at, Google I/O.
Mm-hmm.
We had a slightly different experience at Google Cloud Next, which was our big conference in
Mm-hmm.
April, where we also allowed them after the free throw to do other shooting. So we were tracking them at different points around the court.
Mm-hmm.
So a lot of it really comes down to like, what do you want to track? So
Mm-hmm.
a single camera, it's going to be hard to see like the front of the shooter and the
Yeah.
side of the shooter and the ball, right? So I think each one of those is probably one camera, maybe in
Mm-hmm.
other cases, and we're talking about basketball, but we've built a similar version of this for European football or soccer, as we call it in the US,
Oh,
last year
okay.
for penalty kicks. And then we've talked about doing it for other sports. And for other sports, depending on what you want to track, you may get away with fewer cameras. But in
Mm-hmm.
this case for basketball, right? Or if I was like, hey, I really just want to focus on the shooter's elbow, then maybe the one camera in front would be fine. If I really want to focus on your like side profile of your form versus ball height, you can maybe get away with the one camera.
Okay, interesting. So explain a little bit how it works in terms of like you get the video, right? You're recording the video, and then like you said, it breaks it down by frames. And just walk us through the whole process a little bit slower, and taking in considerations that most people who are watching not technical as me, and as me as well. So yeah.
Yeah, sure. So we record the video of you shooting, right? And then all
Mm-hmm.
that is synced across devices. So essentially, like four views of you shooting a ball, let's say,
Mm-hmm.
or more,
Mm-hmm.
go in for analysis. Some isn't analyzed on your phone itself. So there are models that can do analysis on your phone using the computing power on the phone. So
Mm-hmm.
in this case, that was some of the sort of pose detection and tracking the ball. And
Mm-hmm.
that's a technology called media pipe, which can track certain objects through time. So it'll say, hey, in this frame, the ball is here. Okay, it's up, it's up, it's up.
Mm-hmm.
Here's its
Mm-hmm.
apex, and then it goes down, right? Other pieces of technology get uploaded to the cloud, right? So this
Mm-hmm.
is where we want to do some higher level analysis, things like calling the Gemini model that we had talked about
Mm-hmm.
in not exactly on the phone, but in the cloud, and then return the results from there. So for that piece, we were uploading the video and
Mm-hmm.
again pulling, like one of the important things was pulling out which frames of the video are the ones we want. So if we took a 5 second video, I might release the ball 1 second in, you might release it 2 seconds in, right? So we
Mm-hmm.
can't rely on some sort of timestamp. So the best thing
Yeah.
to do is actually use the large language model's ability to look at video and say, hey, when were they in their crouch, right? I should say, first we slow down the video actually. So it can
Yeah.
look at things frame by frame. So that's done. That's passed to Gemini and then say, hey, which frame of this video
Mm-hmm.
are they in their crouch? Which frame of this video did they release the ball? So Gemini is able to release that frame. Then that instead of the whole video, we take the image from that frame and do the further analysis on there again with pose detection of where's your elbow, where's your hand, right? Are you ideally you want to be at 90 degrees? Are you here? Are you here?
Mm-hmm.
Slightly off or not? And then knees over toes, um, same sort of analysis, right? Like where's your knee? Where's your toe? There's standard kind of pose detection models that capture different points on a person. We just pull out the right ones, calculate the angles we want. I'm making this sound simple. It obviously each one of these takes a little bit of work, but once you have that, like once you have the frame you want and then the landmarks on the person from said frame, right, then
Mm-hmm.
you can make these sort of measurements, calculations. And then in the case of the ball, once you have like the ball trajectory, you can kind of interpolate or get the like, hey, the max height was at this point, and this is the height. And again, I'm summarizing a lot of people's work. I did not do all of this, but we had some great developers, engineers working on this, and they would also like be like, oh, we need to triangulate that to the court, right? Because the camera, it says
Mm-hmm.
like within the frame, this is pixel 13 or whatever. That doesn't have meaning. We need to map that to the
Mm-hmm.
real world, and so we have some calibration done as well to be like, okay, pixel 13 is roughly 11 feet high, right? Something like that.
Okay.
So
Okay. Yeah.
map those, and then based on each of those measurements, again, then we can compare it to our sort of ideal targets, which was based on, again, information from the Golden State Warriors, also as well as like grounding. You can research across the internet like what's a good basketball shooting form, and there's pretty kind of consistent feedback in terms of like where your arm should be, how high the ball should be, what the angle of the ball should be, these sorts of things.
Hmm. Hmm. So the processing when you are trying to understand like about the elbow position and etc., it's being done in the cloud. Is that correct?
Yeah, or at least part of it. Some on device, some on the cloud. But yeah,
Yeah. So that they, like you said, some of the you do it at the beginning and most immediately with the power of device, and then the
yeah,
rest uploads it to the cloud.
yeah,
You you translating the video into the data points, right?
yeah, exactly.
And then
Hmm.
comparing it. All right, and interesting enough, what are the challenges when translating video, let's say, into the data points? Like you said, Pixel 9 doesn't say anything. Like, how do you guys understand if the elbow, like, let's say, 90 degrees or something like that, those metrics?
Yeah, I think there's a lot of challenges in general. So, like, one of the things we experienced as we built it is like we would test it in a certain environment, and then we'd go set up this court at a different conference, and it would be a different environment, right? So the court would
Okay,
not be set up perfectly.
yeah.
So all your sort of testing was based on, hey, the camera looks like this, the lighting's like this, the ball's like this. And if you then move it to a different environment, some of it would work fine, and some of it would be like, oh no, this ball looks different, or the
Uh-huh.
lighting is such that the ball doesn't track as well in the air. So the team had to make some like quick adjustments in a lot of these cases because sometimes you
Mm-hmm.
couldn't. Sometimes you could change the environment, but sometimes you can't. So
Mm-hmm.
yeah, I think like the challenges are kind of like it's just kind of video in the wild. And again, like if you have these really expensive cameras, right, that they set up in the NBA arena and technology that they've worked on for years and years and years, that is like part of that is to fix these sorts of errors
Mm-hmm.
or inconsistencies that you might see in the real world. In our case, we were trying to adjust on the fly with, again, with the technology we had. So a lot of times the trickiness is like, can it pick up the ball correctly in
Mm-hmm.
all instances? In some cases, it was like, it might not pick the right stance of the person or exactly the right moment. Over time, it got better
Mm-hmm.
at these things, and we would track like, okay, it looked like we were off on this. What do we need to adjust? And it's like, in some cases, it's a sensitivity measurement. In some cases, it's prompting it a little bit differently, and these sorts of things. So there's kind of knobs that we sort of set up, and then we can figure out how to tweak as we went.
Okay, so can we say like to make it much better, you'll need to test it in different environments and create a data set to make your computer vision able to detect it on the streets and in different, yeah, environments like this.
Yeah, so I would say like yes, and I'm hopeful that the way like generative AI, like the pace of advancement, is that you won't have to do as much tweaking as you go, right? So like
Mm-hmm.
prior to prior to sort of the recent generative AI trend, you could still do a lot of this with computer vision, right?
Mm-hmm.
But like ask the video which frame, like you'd probably have to have some rules based thing where it would be like, well, the frame where the guy's knee is as low as possible or something, but that may not actually translate to the right thing. So these generative AI models have more sort of like have been trained on like a massive corpus of data, have a lot more world knowledge. So you can basically be like, which frame were they crouching, right? Which is like a natural language question, and you're getting the response back. So I'm hopeful that over time we can be like, hey, track the trajectory of the ball. It can just pick up that it means the ball, like, it doesn't have to look like a specific thing. It can be like it's the basketball in the image. It's not the one, one time we had like a basketball on the wall, like as a marking, and once in a while it picked
Mm-hmm.
that up. So hopefully over time you wouldn't even have to ask these questions. You would just or like it would be very clear to the model what you're asking for, and then it can give it to you without sort of the noise in the background. So like for example, when we did this of the version with European football, soccer, and penalty
Mm-hmm.
kicks, one of the versions we did it, we had a custom object detection model, which is still pretty cool and useful, which would say like
Mm-hmm.
detect this ball. But in that case, we used a pink high contrast soccer ball,
Mm-hmm.
so that it would show up, and we train the model to be like, this is the ball that you want you to
Yeah.
pick up. So that's cool, but now you need training data on that ball. And now if you're like, I don't have a pink soccer ball, like that model will not
Uh-huh.
do as well. In the basketball case, we said, hey, it's a more generic, like track the basketball, and it mostly worked, right? So ideally, those generalizations will uphold more and more as you get and more advanced. But yes, I think in general, it's like great practice, of course, to like, if we're going to use this in the real world, like if it's going to be in 1 to 2 environments, then of course tune it to those environments. If the goal is to use it in different environments, try to make it more general, and you can kind of only do that by taking it to multiple environments.
Yeah, I got you. So you mentioned a little bit, so the difference between, the computer vision and generative AI, just tell us a little bit. So when you're training a data set and you're training a computer to understand the ball, you need to show him like a ball million times. And like you said, if we have a ball in different color,
Yeah.
then it won't understand what's happening, right? But in generative AI case, how does it work?
Yeah, so what I just said with like the pink ball and how you just summarized it
Yeah.
is mostly applicable to sort of traditional computer vision. Now, computer vision traditional sounds like it's old. It's not that old. It's still pretty like recent advancements. But in like the case that what we used is like an object detection model trained again on Google Cloud, where you take a bunch of pictures of the object and say this is
Mm-hmm.
ball and like give me the bounding box around it. And then when you apply it to a new environment and say, hey, this is a picture, give me the bounding box around the ball, right? In our case, we were trying to say how close is a pink soccer ball to reaching a certain part of the soccer net.
Mm-hmm.
So that is kind of traditional. In generative AI, you don't necessarily need to have the pre-trained, and this is true about all sort of the difference between predictive AI and generative AI, right? Predictive AI, a lot of cases, you're going to have a model, and you could still be calling an API, but it's going to give you a very specific response. It's not, and it'll be kind of trained on that data. Generative AI is kind of trained on like the world of data. So it's like it's seen a lot of video, a lot of text, a lot of
Mm-hmm.
images, and it's used to like, answering kind of generic questions about it. So I can ask generic, like take this picture and be like, hey, where's the pink ball? And give me a bounding box around this, and Gemini will do that without having given the model any previous examples of that specific ball, and these sorts of things.
Mm-hmm. Mm-hmm. But yeah, I got you. I understood it right now. But like anyway, someone will need to give it the generative AI, or they need to scrape the info somewhere before you use it, right? So it's still needed
Uh,
to
so,
learn.
so yes and no, right? So like the general idea behind generative AI is like it's um, you probably still need like a data engineering pipeline,
Mm-hmm.
but you don't necessarily need a specific model is kind of the point.
Mm-hmm.
So if you use a big picture model, obviously I talk about Google Gemini, but there are plenty of
Mm-hmm.
others out there. These like large language models, many parameters, right? And they're getting more and more advanced by the day, by the week. These are basically like kind of able to handle many different types of tasks. It can take an image input and give you information about what's in that image without having seen a bunch of your other images or whatever. Now, in some cases, like, do you need to prompt it properly? Of course, you do. Do you need to like bring in other data that will maybe like make your prompt more informed? Probably. But the point is, you don't need a custom model to be like, what is a
Mm-hmm.
basketball, or what is a knee, or those sorts of
Mm-hmm.
things.
Okay, yeah, interesting. So what are the future of this project? How do you see it being implemented, let's say, in ideal world?
Yeah, I think for sort of us at Google Cloud, like try to improve sort of the demo, make it more flexible in all the ways, right? Like let's
Mm-hmm.
not, when there is sort of lighting changes or court changes or basketball changes, make it more robust to those things. Potentially track a few more metrics, right? We settled on a group that we were comfortable with based on what we thought was viable, but maybe there's more that can be tracked that would give actionable feedback. But bigger picture, like if these things were to be taken to, the real world, I think like we were talking about what's the requirement, right? So it's like, do I want live feedback? So you'll see like a lot of these generative models, again, Google's included,
Mm-hmm.
are starting to add these like live capabilities, right? So it's like
Mm-hmm.
you can see what's happening and it will respond to you, kind of in real time. So can we
Mm-hmm.
incorporate the high level analysis in real time, right? So I could put up my phone, have Gemini and be like, "Hey, did I make that shot?" and like it'll probably be pretty good at that, assuming you give it the right angle. But like,
Mm-hmm.
hey, what should I fix? It'll be like, you might need to do this or that, and it may be more generic feedback. But can we work with the sort of technology we have and the sort of live experience to make it more real
Mm-hmm.
time? So I think like if people were wanting to experiment or do more, I think like that sort of aspect would be super interesting. And again, it's like it's doable, but make it like would this be something you use at your basketball camp or while you're practicing, right? Is
Mm-hmm.
the advice like specific and actionable enough, right? It can't just be like, hey, generically, like you should, um, you know, you missed left, so shoot right or something, right? It has to be a little more
Yeah.
actionable than that. So I think like those are the challenges I think I would like to see in the future iterations of this type of work.
Interesting. So, let's say, when do you see every basketball player on the street from, United States to Spain using your product?
Yeah, I don't know. And again, this is like I said, our demo product. I think plenty of startups in the space are working on these sorts of things, and I
Mm-hmm.
think those are super cool. And yeah, I think I can definitely see a place where youth participants in multiple sports are
Mm-hmm.
getting um, at least some actionable feedback from putting out their phones and just showing it. Right now they do it anyways, right? They put their stuff,
Uh-huh.
they use it for social media or whatever, right?
Uh-huh.
But now it can be the same camera, right? That same video that you take can be used as more data for instructional improvement, and I think that can definitely be something I see that in the next 5 years kids are doing that more and more, or parents are
Inter-
helping their kids do it. Hopefully not too much, but yeah, yeah.
Yeah, interesting. Like, and if we think about using this data and this product not only to, improvement in terms of player improvement development, right? But
Mhm.
if we could use this, this product also for somehow for creating a for media and let's say on use level where you set up the cameras and then it somehow tracks right the movement of the game and it could create like a
Yeah,
first view mode. I
yeah.
see it on the highest level right now they implemented, but do you think it will be possible in the youth sports? Just
Yeah,
any
I think
thoughts
that's
on
a
this?
solid sort of extension. I've had a couple
Mm-hmm.
people reach out to me and be like, "Hey, I saw the thing you did. Can I give you video of my pickup game over the weekend?" These are adults, and give me like highlights or when I made the ball, made shots, or like when I played well. And I was like, I think we're getting kind of close, right? So there's a little bit of
Uh-huh.
like if you and I are in the video, I have to be like, okay, who's Alok, who's
Mm-hmm.
Kirill, like I have to probably say it's like the guy in the black
Mm-hmm.
sweatshirt today or whatever the case may be. But like we've done some tests and it's not bad. You do need to then like work with some other tools to actually clip it if you wanted a perfect highlight reel. But I think
Uh-huh.
like that is definitely like the type of thing you're talking about is definitely possible where it's like pick out some highlights or what are some where did I miss shots and then like look at those videos and you don't have to like scroll through, let's say it's like 40 minutes and be like, okay, I took 10 shots but I don't know where they are. You may be able to pull that out more quickly.
Uh-huh.
um, so I think there's definitely room for that as well. And again, like once we get more comfortable with these models and like what information does the model need to actually pick that out, um, and once you kind of again you have to kind of build your data pipeline to be like, okay, what do I want? Something where like I take a picture of everyone playing in the pickup game beforehand and say
Mm-hmm.
this is Alok and this is Kirill, and then
Mm-hmm.
upload that along with the video and say pick out the 5 times Kirill dunked on Alok. Like great,
Mm-hmm.
maybe we can do that. But I think like that's another area where there's plenty of research or kind of fiddling around to be done.
Right, Alex, thank you. So we are about half an hour. It's I wanna have a small blitz with you and ask you a couple sports question. What is your favorite sport?
Good question. I would say overall, basketball and American football are my two favorite. I would
Uh-huh.
pick um, probably basketball from the sense that I've played that in the past
Uh-huh.
as well. But from a fan standpoint, I like both. So
Okay. And then who's your favorite player?
All-time favorite player was Michael Jordan. I grew up in the 1990s, and he was obviously the preeminent basketball player, probably the most
Mhm.
preeminent athlete. So he's my all-time favorite player.
Hey, what is the favorite part of your job? What do you love doing?
Favorite part of kind of my Google job, and even I would say in a lot of my consulting, is learning new technologies and discovering new things. So in a
Uh-huh,
lot of cases in my Google job, like this technology is moving really fast. So it's hard to keep up with. It can be very chaotic at times. But my favorite thing is where I learn something where I'm like, wait, I can do this. I never thought I could do such a thing, or I couldn't do it in this context, right?
uh-huh,
Like if you asked me several years ago, could we track your basketball shot off a video? I would not really understand how to answer that
uh-huh.
question. And now, we feel like we can make significant progress towards answering that questions. And there's plenty of different examples like that. So,
Yeah, so basically continuously learning something new, which is really interesting. And
yep.
if it's not feeling like a job and work, right? It's feeling like something really interesting that
Yeah, I
cool to
mean, those
do.
are the highlights. When it doesn't feel like a job, right? That's what ideal, right? You're like, oh man, I'm like having so much fun. I don't, I'm not feeling like I have to force myself
Uh-huh,
to do it. I'm actually like invested in the pursuit or the knowledge or the
uh-huh,
even the sharing of that knowledge, right? In my job, a lot of it is to communicate that to other people. If you're excited about it or you think like, hey, we've really found something here, and this goes beyond sort of generative AI, like where we have a metric, that helps explain this part of the game or this part of like something important to the league. That's very
uh-huh.
exciting, but it's that discovery phase, I think.
Okay, then what is the worst part of your job?
Um, let's see. Uh, I think a lot of it is, that it's a job. So like there's a lot of administrative pieces and like, you want to do something, but you have to work in the
Mm-hmm,
context of an organization. So a
mm-hmm,
lot of that is like challenging. You have to talk to several people, get approvals. Maybe it doesn't work the way you want.
mm-hmm,
They have requirements as well. So I think I would say like a lot of the challenges are sort of um, administrative, for lack of a better term.
mm-hmm,
But this is like
mm-hmm.
not super specific to my job. Like here, I think this is a challenge a lot of people face. So.
Okay, and all right, Alok. So we are about to finish. I'd like to ask you if you have some thoughts that you'd like to share with our listeners.
Yeah, I think we can kind of build on the last couple points. Like I think it's an exciting time in sort of generative AI for sure, and I think for the nexus of that and data science. So
Mm-hmm,
possibly a lot of your listeners are into sports analytics, into data science. I think like the good news is like there's way more like jobs and interests and conferences and all this sorts of stuff in this industry than when I got started, let's say almost 2 decades ago. But the challenge is, right, like the stuff that we were doing then is now pretty table stakes, pretty easy now. So
mm-hmm,
where can the technology, where can the methods take us to do, these greater things like the things we talked about here? I would, kind of challenge people to explore that. Like, especially some of the younger folks, like they may even have
yeah,
advantages because they don't know like what they're not biased towards some certain line of
uh-huh,
thinking that I maybe have from 10 years or stuff. So push the envelope with the new technology. Still we want to solve maybe some of the same problems, but we can do it in a
uh-huh,
different way, or stuff that we didn't think we can approach, we can approach. So
uh-huh.
just kind of challenge your listeners and others to think more deeply and how you can do better with what's available today.
Yeah, if someone like young folks want to create something in sport tech, how would you go about it? What advice would you give to them?
Yeah, I think so kind of read widely about like the approaches that have been used. So like if you have a particular sport and a particular area of interest, I want to understand this part of a certain sport. Read about what's been done because again, it's been force analytics has been around a while now, so you probably something has been
Mm-hmm,
done. understand it as well as you can, and then say, okay, do I want to advance this? Can I make it better? And then understand again like what technology or data is available to you that maybe is newer or better, so that you can answer the question differently or better, or like maybe try to build something that hasn't been built, right? Like there's a lot of things with
Hmm.
generative AI that I think like now we have a way to like analyze text data in the same way
Hmm.
that we had to analyze numbers in the past, or
Hmm.
images or video. So what does that unlock? So I would say like think, come up, start. I think starting with a good question and having background is still kind of paramount to me, but
Hmm.
then open it up from there. And if you're familiar with generative AI, I don't think it's super hard to get started. Certainly we have a lot of resources at Google, other places do as well. So you can get started pretty easy, and then try a bunch of things. Be like, okay, this looks promising. Let's pursue that direction.
Awesome, Alex. Thank you so much for insightful conversation. It was great to have you. It was awesome.
Yeah, thanks so much for having me. Appreciate it.
Bye.